Part 4, Applications of Parabolas. A parabolic arch that is 10 feet wide at the base and 18 feet tall in the center is constructed on level ground. How far horizontally from the center of the arch should a light be attached so that it is 7 feet from the ground? So I'm going to make sure that the vertex is on the y-axis just to make this easy, and I'll let the ground be the x-axis. So this point right here is the point 0, 18, because it says that the arch is 18 feet tall. We also know that the arch is 10 feet wide at the base. So 5 feet in one direction, 5 feet in another direction. So that gives me 2 more points. Now this is opening down, so I know the equation should be x minus h squared equals 4p times y minus k. And hk is 0, 18, so x minus 0 squared equals 4p times y minus 18. So that's what I know so far. I have no idea what p is, but I can find it because I know another point on the graph, 5, 0. If I put in 5 for x and 0 for y, I should be able to find p. So I have 5 squared equals 4p times 0 minus 18. So 25 equals negative 72p, and p is 25 over negative 72. So my equation looks like x squared equals 4 times 25 over negative 72 times y minus 18. So that's the equation for my parabola. Now I want to know how far horizontally from the center of the arch should a light be attached so that it is 7 feet from the ground. So here, if it's 7 feet from the ground, then my y value is 7, and I want to know the x value. So I will substitute 7 in for y, and then I can find x. So I have x squared equals 4 times negative 25 over 72 times 7 minus 18. I put all that in the calculator, and I get x squared is approximately equal to 15.28 feet. Take the square root of both sides, and I get x is approximately 3.9 feet. A searchlight is shaped like a paraboloid. A paraboloid is a three-dimensional parabola, is how to think of it. If you take the parabola and you spin it around the axis of symmetry really fast, you can start to visualize what you'd see, that three-dimensional parabola. So we have a light source located at the focus. So if I have a parabola here, and I'm going to put the vertex as 0, 0 to make this easy, and then we have a focus right here, which would be the point 0, 1, or 1 up from the vertex. It says that the focus is 1 foot away from the vertex. And the opening of the searchlight is 3 feet across. So if it's 3 feet across altogether, then this point would be 3/2, comma, whatever the depth of this is. And this point over here would be negative 3/2, comma, whatever the depth of this searchlight is. So the opening of the searchlight is 3 feet across. Find the depth. So what do I know? I know it's opening up, and I know that my vertex is at 0, 0. So I have an x squared equals 4py. I also know that p is 1 because that's the distance from the vertex to the focus. It already tells me that. So I have x squared equals 4 times 1y. So x squared equals 4y is the equation. And I want to find the depth. So the depth would be the y value when x is 3/2. So if x is 3/2, I have 3/2 squared equals 4y. 3/2 squared is 9/4. Divide both sides by 4, and I get 9/16 equals y. So the depth is 9/16 of a foot.